Hi, I'm Palazzo, and I'm going to show you how to assemble the controller. So the controller mostly will look like this when it's all assembled, but this is actually a few pieces of 3D printing, so put that aside. The real brain of the controller is this guy right here. It is a SparkFun ESP32 thing. Of course, runs off the ESP32. It has a charging port for getting its Wi-Fi information from, as well as charging the battery, which is plugged in here. This is the battery. It is a 2 amp hour battery. It is specifically, this one is from Adafruit, but I also have a 3D print that works for a SparkFun battery as well, also 2 amp hour. There's a little LED on here to give feedback when from the code to tell you what the board is doing. There is also a Wi-Fi antenna on the back here. And there's 2 buttons as well, but those will be covered up by the time this gets used. So anyways, we're going to take this board, and I've made this board to house everything. Of course, this guy will go on top near the center here. Then the resistors next to that, the transistors here, and the connectors there, and mirrored on the other side is the resistor, transistors, and connectors. Here's a diode here for backwards voltage, flyback voltage, or flyback diode, I think they call that. And then here's a button, and it's a resistor. And that button is what you press on the controller to turn it on or off or factory reset it. So, before we start soldering anything onto here, there's something important. We must break power LED connection before soldering board. And what that means is that when we take this battery here and we plug it into this board, what happens is that this little red light comes on. That simply means that there's power on this board. And we don't want that. We want only this blue light, and right now this blue light's just flashing the basic hello world flash because it's a brand new board. But we don't want that red light to come on because this battery will always be plugged into this board. So what we got to do first is break this little connection right here that says power LED. So I'm going to go ahead and run my screwdriver over that, being careful not to cut any other leads as I do that. And this is kind of hard to do, perhaps on purpose. And if you ever want to repurpose this board, that's why there's these 2 pads here as well, to resolder this easily. But for our purposes, for the haptics project, we do not want this. Let's see if I got it. I'll plug it back in. Nope, I did not get it. It's still there. 1 second. Okay, now broke that solder connection properly, and when I plug this in, oops, the correct orientation. It's a good thing that's keyed. It does not turn on. But we can see the blue LED come on eventually and start running that program still. So that's good. So now the next thing I want to do is solder the headers, that is these rows of pins here, which will connect this board and this board together. So we'll go ahead and solder these up. Now the way I like to do it, of course this is up with that on top. So I like to put the short end of these guys down into the whiteboard. Let's see if I can zoom in for you here. The whiteboard, cool. And then I'll take this board, put that right on top of it. So that's what it will look like eventually. But I want to put the red board on here now so that when I flip this over, for one, it keeps the pins in, and 2, it keeps the pins straight. Also, you see, I included a little window here in the board itself so that if you ever do not cut that LED and then you plug it in after you've soldered everything up and you're like, oh no, well then there's your get out of jail card right there. So I'm going to start by taking my soldering iron and my solder here. I'll just go ahead and solder at one corner. Good. Solder in the other corner. Good. And likewise on the other side. So I'll start with this on either corner. So I'll put the nodes exactly where, or not nodes, sorry, exactly where the headers need to be. Now I can lift this off. I can pull this guy off because he's already set, because they're soldered in place, so we're good to go. So now the rest of this is just me soldering these other, goodness, 36 pins in. So one moment. Alright, now with those all soldered, going to go ahead and flip this over, and the next thing I want to do is all the connectors, since the connectors are about the same size as that guy. Now this is a little tricky task because the connectors, you gotta hold them in properly, and they won't probably take the correct orientation when you put them in. So what I like to do is just dab one of them with some solder. Okay, he's soldered in. And pick it up again. Look at the straightness of that. Oh, it's not straight, so I put my finger on it. Preferably not the one that's soldered. If you can see it, the soldered one is the third one in. My finger's in the first one or two. So I'll grab that, I'll melt that solder again, bring it back up with my fingers to level, and there we are. So then I just put that down and solder the rest of those guys in. Nice and simple. So that takes a little bit of time. So with the magic of editing, I'm done. Look at that, got all the connectors soldered on. So now the next piece I want to solder in is the controller itself. Now let's see here, the controller goes just like that. It has those long pins sticking upwards, and that's okay for my design. It doesn't hurt, and it kind of saves you from having to clip all those off in the end anyways. And the reason I want to do the board next is because I want to save the resistors until after I've done the board, because the resistors will sit next to the board and get slightly tipped by them. So let me put one in here real quick. There we are. So I don't want to have to solder the board past those resistors because they're pretty close. So I'll leave that for after the fact. So similarly to how I did the original headers, I'll just take the corner pieces here and I'll solder those down. Come on, there we go. And likewise on this corner, so that it is soldered in. And so now, let's go ahead and do that on the rest of the board. Just like that, it's all soldered in. The only difficult part was next to this connector here. That's a pretty tight spot, but you know, just kind of put the solder vertically next to those and kind of feel them in with the soldering iron, and it's not that bad. Okay, so the next things I'm going to want to solder in is this little 6mm button I have right here. It is 5mm tall, and that's important. A few of these you'll find are like 6mm tall, and that won't work with my design. However, of course, you can modify the design as you please. It is open source. So we'll just put the guy right in there, and it snaps in real nice. So all we gotta do is just do a real quick hit of these 4 pins on the board. And he's done, just like that. So now, also considering with the board, or the button that is, I have, let me zoom out here, I have 16 100 ohm resistors and just one 10,000 ohm resistor. The 10,000 ohm resistor, zoom back in, is a brown, black, orange. A 100 ohm resistor is a brown, black, brown. So you can kind of see it's a very slight difference. So make sure for sure that is the correct resistor. In this case, again, is the brown, black, orange. Of course, if you're wondering what the gold is, that just means how much intolerance that resistance is. So this guy goes right there on the board. The only 10,000 ohm resistor. He is specifically for the button that's right there. So flip him over. He's sticking pretty nicely. Don't have to worry too much about him. And I'll just give that some solder. Is it sticking up properly? Does it look good? Yep, that looks good to me. Of course, you won't see this from the outside of the controller anyway, so it doesn't matter too much how this guy looks if he's tilted too much one way or the other. And there is no polarity on resistors, so don't worry about that. And I'll just go ahead and cut those 2 legs off right there, right there. There we go, they're off. Trash them. Cool. So that is the button done. So next, I'm going to take the resistors, all the other 100 ohm resistors, and start putting them next to the board. Again, there is no polarity on resistors, so it doesn't matter which pin goes into which hole. But as you can see, it is from top to bottom 8 on this side, and then top to bottom 8 on that side. So very similarly, just to do the first one for you, solder that guy in, then solder that guy in. Okay. Does it look good? It looks good. Yep. There's not much I can really do to mess that one up. And then take our snippers, snip. There's my legs. Can toss those or save them for other projects, which I do sometimes. But there we are. And so now, go ahead and do the rest of the resistors. And there they are. All the resistors all soldered in. Looks good. Also, I also forgot to mention, make sure they're all the right color before you put them in there, because it would be real unfortunate to put like the wrong color in the wrong spot. Fortunately, we only have one different resistor here versus the rest of them. So now, the diode. The diode is a very standard diode. The only purpose to the diode is to prevent backwards voltages. And to give you a little information about that, when a motor is running and then stops, it still has kinetic energy in itself, and therefore it will, once the power has been dropped to it, it will continue to spin, creating itself as a generator and causing voltage to go backwards through the system. What this diode does is it drops the power from ground back to positive. Ground to positive if it's going backwards, therefore it preserves the electronics. So just put the diode in there. As you can see, the diode has one side that is marked on the board and the one side is marked on the diode. So right there, it's in. Just grab that and move those apart. And then we'll just solder those in. Some thick legs, so it requires some extra time to heat. There it goes. Okay. And simply just take off the excess. Those legs are extra thick and they're extra hot. Hurts my fingers. It's okay. We're good. So there we are. There's our diode soldered in. Now, next thing we're going to want to do is the transistors. Here is a transistor. It is what actually drives the motor. The board does have outputs on it that drives these transistors. However, they are not powerful enough to handle the current of the motors. So what we do is we take a transistor to drive the motor, and the resistor here powers the transistor. So now what's really important here is the transistor does have polarity. If we take a look at the transistor here, it has a circular side and a flat side. So the flat side is marked here on the board. As you can see right there, the flat side and the circular side above that. So we're going to take our transistor, excuse my fingers for 1 second, put that in there. There it is. So now our transistor orientation lines up with the drawing. Very cool. So the only things that really matter for orientation here is, well, I guess the board, the SparkFun board on the whiteboard, the diode, and then the transistors. Everything else, I believe, does not matter the orientation. So anyways, what we're going to do with the transistor is the same thing we're going to do with the connectors. Is we're going to hold it, flip it over, drop it down, and it's going to fall a bit to the table beneath it. I'm just going to solder one leg in. There it is. It's soldered. I flip it over. The transistor doesn't have to be pretty. It doesn't even have to be down all the way. But I don't know. The perfectionist in me says not good enough. So what I like to do is I hold the top of the transistor and I give that solder a little extra heat to bring it all the way down to the board, make it straight up and down. There we go. And then come back to here and solder the other two legs in. There we are. Wonderful. Now we take our snippers, grab all three legs at once, snip them all off. There we are. Throw those in the trash, and I'll go ahead and do the rest of it. Oh, before I do though, notice that one side of the board has all the circular sides down, and the other side of the board has all the circular sides up. That's important, because that's just how the board's laid out. So be sure to do that. And so now, here we go. And just like that, we have them all soldered in. Not exactly perfect, especially this one right here. Oh my goodness, it's going to drive me nuts. However, it's okay because you don't see those when the whole thing's assembled. So, let's actually assemble it now. Let's put away the soldering stuff, unplug the soldering iron, and then let's assemble this guy. So, we have our pieces here. This is the top layer. What it has on it is a hole to charge it with. It has a hole for the power button. It has the 1 through 8 plugs here, then 9 through 16 plugs here, and then it has some holes to screw into the rest of everything else. That's about it. Now the power button is this little red piece here, and the power button, as a side note, is printed on its side, which means it's printed like this. And the reason is so that the layers of the 3D printing don't mess up the button, which happened on earlier versions. And that goes right into this hole, well, not like that, but goes into that hole and pushes down, and the lip will sit on the side like that. Now it's a little tight, well, not exactly tight, but it can hold itself here usually as you need to put it in the part. This piece here has a single hole in it, actually holds the board. So I can take the board and put it right here on top. And there it is. That's the board holding piece. Cool. And then this is the battery piece, and it's also where all the screws screw into. So now this is the Adafruit battery version. The Spark Fun battery version is bigger to accommodate that guy. And it has a channel for the battery to go through. Now each of these holes is tapped hole, that is, it accepts a screw. I like to take a M3 by 0.15 tap when I'm putting these into the to put the tap into these holes first so that the screws go in much easier. And at the bottom here is part of the mounting where you can take a strap of either Velcro or nylon, as you please, put it into here, and these little spikes that are inside will help hold that in place. So I'll put that aside. So what we want to do is start with our bottom board here. Our bottom board has a battery into it. And we're going to take this one little thing and, just as I know to do already, pre-fold this over so it has the extra slack in this little pocket next to the battery. So then we take this piece and slide the battery connector through there, just like that, and then we can put them on top of each other, and there we go, they should fit flat. Now we can take our board, we can go ahead and plug it in, and then we can just fit that right back into there and put the two pieces, kind of hold them together. So there we are. Right now I can't turn the board off because I don't have that program loaded. It goes into a sleep state, not really off, but there we are, now it's in. So I can take my top board here and just put that right on top of, just kind of wiggle it in there. There we go. We are in. And so this is a controller, all nice and stuff. Now what I want to do before I actually start here is I want to take a node connector and just kind of put it onto one of the connectors right there. What that'll allow me to do is kind of keep those lined up, because there's a little bit of play left and right in the board right now. So I have these 4 M3 by 20 millimeter screws. I'm going to go ahead and take those and just kind of wiggle them in. Here's another one. Wiggle it in. Take that, put it in there. Okay. Bottom board. Okay, get the boards mostly lined up there. Good stuff. Now I'll go ahead and take this and just run these screws down. Allen wrench, by the way. I don't know if you can see that. So there we are. Those are going in really nice because of the tapping beforehand. I'll just do a mostly fit on here. Now, one thing you do want to check though is that you don't have any gaps between these layers. That's, you know, that you may be pinching the battery wire, which would be no good. But while I'm screwing this down, let me tell you a little bit more about the battery. The battery is protected for overcurrent, so you can, so just in case wires get crossed, the battery should protect itself, protect your device, and not put out too much current. These threads are threaded into plastic. The bottom piece here is where the thread is for these. The other two pieces above are just through holes. So, you know, take caution when you are putting force onto these threads, so there's not too much thread that you strip out that bottom piece, because that would be not good. And when you keep bumping the camera, that's no good either. But as we keep going, you should see if there is any gaps in the pieces. When you screw it down, those gaps should close. Of course, you know, make sure that you're not screwing down the battery wire, because that's no good. Alright, so now they are all in. Let's see, our button works. Excellent. Good, feels good. There's my connector for my power right there. Really good. Go ahead and pull that out, don't need that anymore. And there it is, an assembled piece. Now I do have 3 holes at the bottom here, 1, 2, 3, if you could see them over this finish here. That is for this plate. I also have designed a clip. The clip is only uses 2 of those 3 holes, and the clip is if you wanted to, you know, put it onto a belt buckle or something like that instead. But I like the nylon strap idea more, so I'm going to go ahead and line that guy up there, and I have 3 M3 by 10 millimeter screws. I can go ahead and just screw down there, similarly like that. And won't go through the whole process, but you know, there it is. It screws into those 3 holes. There we are. And of course, you got to put the strap in before you put all the way down, or else that's not going to work. But there we are. So my next video will be on how to actually load the program in, and then configure the device, the controller that is, for your Wi-Fi, and then actually see it pop up on the program. Thanks.